we're going to get practice doing another approximating area problem here. And we'll do some more practice with this in class. And then in class, we'll ask, how do I get the exact area under a curve? That will be a good question to ask and answer. So let's try and approximate the area under the curve y equals 2 plus ln of x on the interval from 4 to 8. And we're going to do this in a couple different ways. Ln of x plus 2 looks something like this. It doesn't cross at a very nice number. So we've got 4 over here and 8. Okay. And so we want to use 4 rectangles and write endpoints. Okay, so 4 rectangles, let's first of all figure out how wide each of those rectangles is going to be. So our delta x will be 8 minus 4 over 4, which is the number of rectangles. We can oftentimes think of this as a and b, and the 4 is n. So the general idea is b minus a over n is how many rectangles or how wide each of the rectangles is going to be. That's going to be useful eventually. So that's our delta x. So in this case, that will simplify to 1. So the width of each rectangle is 1. If we look at our interval from 4 to 8, that also makes sense. So if we're using right-hand endpoints, we'll use the 5, the 6, the 7, and the 8. So if I draw my little rectangles here, I'm going to draw things better here. Sorry, guys. So let's just make our natural log look a little bit more interesting. So I'm getting my rectangles here. We notice that these rectangles all go above the curve. So it's going to be really easy to tell that this right-hand approximation is going to be an overestimate. Okay, and even without figuring out what that estimate is. So now we need to find the area of each of those rectangles, which means we need the heights of each of them. The height of that first rectangle will be f of 5, where this is my function. The height of my second rectangle will be f of 6, since we used the 6 to get the height there. And then we'll have f of 7 and f of 8. So those are the heights of each of our rectangles. Then we have to multiply those by the widths, which is our delta x. So we multiply all of that by 1. Now it's really just typing things into a calculator. So we're typing our values into this function. When I type this in, I got 15.437. Just kind of for fun, we could notice that if we write this in summation notation, we've got our delta x times f of x sub I, where I goes from 5 to 8. Or actually, that's not x sub I, that's just an I in this case. So I plug in 1, I plug in 2, or I plug in 5, I plug in 6, I plug in 7, and then I plug in 8. Delta x we could write as just a 1. I'm trying to use this to get us towards what we're going to do when we do exact area. Okay, so now in this one, next one, we're going to do 2 rectangles and left endpoints. So if we do 2 rectangles, our delta x will be the whole length is 4 divided by 2. So the 2 will be the width of our rectangles now. So the left-hand endpoints will be at 4 and at 6, since these are too wide. Again, this is very easy to see that this is going to be an underestimate this time because all of our values, all of our rectangles lie under the curve. And so finally, if we want to approximate this area, we're going to have f of 4 will give us the height of this rectangle, and f of 6 will give us the height of the other rectangle. We have to multiply that by our delta x, by the height of the rectangle. So we're multiplying by 2 in this case. When I do that, I get 14.356. That's closest to our previous value, but we notice that this one is smaller than the previous one, which is good because we expected the first one to be an overestimate and this one to be an underestimate. Okay, and now finally we're going to use midpoints and 4 rectangles. Since we're using 4 rectangles, our delta x will still be 1 like it was in the first case. Midpoints are going to change what the height of the rectangles are. So we do 4, 5, 6, 7, and then 8. The midpoint between 4 and 5 is 4.5. So this rectangle will go up like that. So the height of that first rectangle is f of 4.5. The height of the second rectangle will be f of 5.5. And then you might believe that we're going to get f of 6.5. from this one, and f of 7.5 from that last one. So let's do f of 6.5 and f of 7.5. We have to multiply that all by the height of the rectangles, which is 1. When we do that, we are going to get 14.585. Okay, with the midpoints, it's a little bit harder to tell whether this is an over or underestimate. If we think hard about it, enough about it, sometimes we can figure it out, but it's not quite as obvious because everything's not under the graph or above the graph. The real question is like, is this stuff bigger or smaller than this stuff? So like, did I include more than I left out? That would be kind of what you would be asking if you wanted to try and figure out if this was an over or an underestimate.